Now let's do an exercise where we estimate beta of Yes Bank. Now I have 5 years of weekly returns of Yes Bank in my spreadsheet, so let me go to that spreadsheet. This is my spreadsheet. These are my returns of market, and I've assumed that the market is CNX 500, and these are my returns for my stock, and I've used Yes Bank as my stock RI. These are weekly returns, and I have 261 observations for 5 years. Okay, now I run a simple regression, and you can do it by going to data analysis, and then going to regression. You select Yes Bank returns as your Y, so this is your Y. You select CNX 500 as your X, so this is X, and then you can run the regression and you can get the results that I already have. So let me just discuss those results. So let's look at them one by one. The first thing is the intercept. The intercept for this regression is 0376. Now this means that this equation and the beta is 1.4051. This means that this equation is something like this: Rm Ri is 0.00376 plus 1.4051, which is my beta, into Rm. This is the equation that I got. Okay, now I have also plotted this line, and this is how it looks. My x-axis is the market returns, and my y-axis is the returns on Yes Bank, and this is my equation for the line that you can see in orange here. Okay, so this is my best fit regression line, and I discussed how do you get this line, and all these blue points are individual data points. So for example, when for a particular point Yes Bank had a return of 0.04%, whereas the market went down by 15.28%. Sorry, it's the other way around. Yes Bank went down by 15.28%, whereas the market increased by 0.04%. So it's X and Y. So this is one particular observation, and similarly I have 261 such observations, and I've used it to estimate this best fit line that you can see in orange. This is my regression line, this is the equation of that regression line, and these are my outputs. Okay, so let's look at beta. Beta is 1.40, which means that if my market increases by 1%, on an average Yes Bank increases by 1.4%. This is what this regression equation also suggests, that if I increase Rm by 1%, then my Ri should increase by 1.405%. And the same holds when the market declines. Yes Bank tends to decline more, around 1.4%. Now let's look at this standard error. What does the standard error tell you? I told you the standard error is nothing but the standard deviation if you make a distribution of all sample averages. Like I showed you in the class today, if you make a distribution of all sample averages, and this beta is a kind of an average that you got from this particular sample of 260 observations. So with another sample of 260 observations, you would have received some other beta, and with another sample of 260 observations, you would have received some other beta. If you look at the distribution of all these betas, it will have a standard error of this, right? Which means that because of central limit theorem, you can assume that this distribution would be normal, and it is easy to see why this should be normal if you know central limit theorem. Now, if this beta is 1.40 and it has a standard error of 0.15, if you remember this rule of 66, 68%, 95% that we discussed, where is it? If you remember this rule, this is what your standard error means. 68%, with 68% probability, your beta would lie between 1.4 minus sigma and 1.4 plus sigma, and sigma is this 0.15, which means with 68% probability your beta lies between 1.4051 plus 0.1514 and this. So although you got a beta of 1.401, this is the estimated beta, but you are 68% confident that your beta lies between this range. Now, in statistics, as you would have done in your statistics course, generally we take a confidence level of 5% or 95% confidence. If you want to be 95% confident, then you are really looking for mu minus 2 sigma to mu plus 2 sigma range. So what you're really looking for is this. This is mu minus 2 sigma. And this is mu plus 2 sigma. So you're 95% confident that your true beta, which is your population's beta, lies between this range. Okay. Now the problem that really happens with low observations is this. Here you have reasonably large number of observations, 260 observations, but suppose you had just 20 observations. You would find that the standard error increases from 0.15 to something like 5. If it increases to something like 5, you would be able to make absolutely no statement about what your true beta is, because your range would be so large. You would say that I estimated a beta of 1.41, but, or let me show you this. Let's say I take just 30 observations. Just 30 observations I have. Now let me run the regression. I go to data analysis. I do regression. This is my y. And this market is my x, and I have labels. First row is labels, CNX 500 and yes bank. Okay. Let me have my output here, and that's it. The constant is 0 would force your alpha to be 0. You don't want to do that. This is what you get. So your beta is still not very different. 30 observations got you 1.41, and with 260 observations you were getting 1.40. So your beta hasn't changed much over the last 5 years. So with 30 weeks data, you have less than 1 year of data, and in this example, you have 5 years of data. So your beta hasn't changed much. Look at the standard errors. Standard error has increased significantly now. It was 0.15 here, and it has more than doubled. So the statement that you could make with 95% confidence is this now. I'm 95% confident that my beta lies between this value and this value. Okay. So this is a much wider band. Here you were saying it's around 1.1 to 1.7, but now you are far more uncertain. Now you are saying it can be anything between 0.7 to 2.14. So your standard errors have increased. And what if you were using annual data of last 5 years? You will have just 5 observations, and your standard errors will be much larger. So this is why you need larger sample sizes. Okay. So we have discussed the intercept. This is what you see here, where this line is actually meeting the x-axis. This is your intercept. It goes here in your equation. We have discussed beta, and we have discussed the significance of standard errors. Let's look at t statistics. T statistics effectively tell you whether this particular coefficient that you have estimated 2 coefficients, alpha and beta. Alpha is 0.076 and beta is 1.4051. Whether these estimates or these parameters are significant or not. Now with the intercept, the t statistics is just 1.21. Its p value is 0.22, so it is not significant. Whereas p value less than 0.05 is considered significant, is that you say that there is more than 95% probability that this is different from 0. Now there is upper and lower bounds at 95% level, and with beta you can see these are the things that we have already calculated. This is not exactly same, because this is not 2 sigma is not exactly 95%. It's actually 1.96 sigma, which is 95%. So there is a slight deviation, but this range we have already calculated here. So we are saying that we estimated a beta of 1.4, but we are fairly confident that it at least lies between 1.1 to 1.7. We are 95% confident. This beta is also significant, which means that market returns are a significant predictor of yes bank's return. This is what it says. Market returns are a significant, this is, by beta being significant, this is what we say. Market returns are a significant predictor for yes bank's returns. And we are talking about weekly returns here, and you should find this to be true in most cases. Okay, so this is about beta and intercept. Standard errors of beta we have discussed. Now let's discuss R squared. So there is your R squared here. Yeah, this is your R squared. It's 0.024, which basically means it's roughly 25%. What does this mean? R square of 25%. It means that 25% of the variation in yes bank returns can be explained by the market index. Or you can say that 25% of the risk that yes bank has, which is driving the returns, we assume 25% of the risk is market risk and 75% is firm specific risk, or if not firm specific, let me call it specific to be more general, because it can be industry specific risk. So there is some risk related to banking industry which is different from market risk. So 25% is market risk and 20% is market risk. When you look at yes bank returns, 25% of the returns are driven by market risk because they can be explained by market returns, and 75% is specific risk. Okay. So that's about it in terms of estimating beta using regressions. Let me take a pause here.